Good morning, my students. We are going to study the electromagnetic induction for grade 12A and B. If you have a coil in the form of U-shaped magnet, this is a coil in the form of U-shaped magnet. This coil made of soft iron and wire is wound around it in one direction, equal and opposite in the second direction. The terminals of the coil connected with the neon lamp. This lamp connected with a battery of 6 volt and switch in closed circuit. This battery is 6 volt while the neon lamp needs potential difference 180 volt. This is a switch. This is called electromagnet made of soft iron. When the circuit is closed, the current passes through it. This current produces magnetic field. Magnetic field changes through the turns of the primary coil of the coil. This change in the magnetic flux produces induced EMF, but this circuit is closed. When the circuit is closed, induced EMF is called backward induced EMF. But the neon lamp does not glow. When the circuit is opened in very short time, backward induced EMF is converted into forward induced EMF and the lamp flashes. Because epsilon induced directly proportional with the delta phi m over delta t. This is open in very short time. This means that induced EMF increases and the lamp flashes. During opening the circuit, that between the terminals of the switch, electric spark is produced. This is called self-induction. But if we have two coils, one of them connected with a source of electric current, while the second connected with galvanometer like this is coil in the form of solenoid connected with a battery and rheostat, while the second solenoid connected with moving coil galvanometer. The first is called primary coil, while the second is called the secondary coil. When the primary coil belonged inside the secondary coil, change in magnetic flux takes place, produces induced EMF, which can be observed during or through moving coil galvanometer. This is moving coil galvanometer. When the secondary circuit is opened, this secondary circuit, which connected with the moving coil galvanometer, current almost vanishes. In the primary coil. Give reason why current vanishes. Because self-induction in the primary coil generates backward induced EMF. The coil by itself producing backward induced EMF balance EMF of the external source. If the source EMF connected with another coil and the circuit is opened like transformer, this is transformer, the example transformer This is a wire connected with the source, but this source is alternating current. Transformer works by using alternating current. And the second side, open. The second side is opened. When the second side is opened, secondary coil is opened, the primary coil form backward induced EMF equal and opposite to the EMF of the source. So there is no current pass through the circuit. Balance EMF of external source where the small part of energy consumed through the resistance. The electric transformer cannot be used to step up or step down DC current. What is the function of transformer? Transformer device used to step up or step down alternating voltage, not direct voltage. Transformer can be used at generating station to step up voltage, in the same time step down electric current to avoid melting wires, to transfer electricity from generating stations to the zones of distribution. But when we use direct current, the magnetic field is constant. While this apparatus, based on mutual induction between two coils, mutual induction between two coils takes place due to transfer delta phi m over delta t from the primary coil to the secondary coil. Delta phi m over delta t, rate of change of magnetic flux, while direct current produces fixed magnetic field. This means that the magnetic flux, delta phi m, due to direct current is constant in one direction. This means that there is no induced EMF. There is no induced EMF generated in the base of the electric transformer working. So the transformer does not work. The induced EMF in the primary coil depends on the rate of change of magnetic flux, delta phi m over delta t, rate of change of magnetic flux. Induced EMF in the primary coil limits the electric current passing through it. So, not to increase, but burn the primary coil. When we use a step-down transformer can be used at a distribution station to step down voltage and step up current to be suitable for using in our homes. Step-down transformer decreases the potential difference considered circuit, and vice versa takes place because V inversely proportional with current intensity in case of alternating current, but V is directly proportional with the current intensity at constant temperature according to Ohm's law in case of direct current. This is give reason. Because the power is constant, so the potential difference inversely proportional with the current intensity based on the relation I equal power over V. I and V inversely proportional to each other, inversely proportional with each other. Now, we study the types of transformer. The first transformer is called step-up transformer. The second transformer is called step-down transformer. Transformer composed of primary coil connected with a source of alternating current. But the frequency at primary coil equal frequency at the secondary coil. Frequency primary coil equal frequency of the secondary coil. This transformer contains a certain number of turns. The number of turns of the primary coil less than the number of turns of the secondary coil. This means that the number of turns is a step up. يبقى this is called a step-up transformer. A step-up transformer can be used and at generating stations only. Raise the potential, the power of a station at the power of a station. يبقى increase the potential at power of a station and in the same time decrease the current intensity to avoid melting wires. The number of turns in the primary coil less than the number of turns of the secondary coil. يبقى this means that number of turns of the secondary coil greater than the number of turns of the primary coil. A number of turns directly proportional with the frequency or with the potential difference. This means that a V of secondary, potential difference of secondary is greater than a potential difference of the primary coil, like a number of turns, because both of them directly proportional. While the current intensity inversely proportional with the potential difference. This means that I secondary less than I primary. In the last step, V secondary greater than V primary. In this case, I secondary less than I primary. This means that the potential difference is inversely proportional with the current intensity. But we use now a step-down transformer consists of insulated thin iron sheets made of siliconic soft iron core, thin insulated sheets to decrease the eddy current, because thin means small area inversely proportional with the resistance. This means that resistance is high, resistivity directly proportional with the resistance. By increasing resistance, resistivity increases, and the eddy current inversely proportional with the resistivity. When the resistivity increases, the eddy current decreases, which produces heat energy to prevent melting core of the transformer. But in this state, the number of turns of the primary coil is greater than the number of turns of the secondary coil. The primary coil connected with the source of alternating current. This is source of alternating current, not direct current. This means that the structure of transformer is composed of primary coil composed of number of primary coil made of copper, which has low resistance to produce small heat energy in the form of lost energy. While the secondary coil also consists of copper, which has low resistance, because part of energy is converted into heat energy through primary coil and secondary coil. To decrease it and increase the efficiency of transformer, we use wires made of copper. This is a step down, lower electric potential distribution. V decreases and I increases in this case. The number of turns of the secondary coil is smaller than the number of turns of the primary coil. The voltage at secondary coil is smaller than the voltage of the secondary coil, and the current intensity of the primary coil is smaller than the secondary, or the secondary greater than the primary, vice versa, inversely proportional according to law of conservation of energy. At end, goodbye and good luck, my students. ده تبعهم هو ممكن now we study some problems about electric transformer. If you have a step-down transformer of efficiency 100%, this means that this is the ideal transformer, is required to be used to operate an electric lamp of power station. This lamp is connected with the secondary coil of power equal 24 watt and potential difference 12 volt using power source EMF at the primary coil equal 240 volt. If the number of turns of the secondary coil is N secondary coil equal 480 turn, calculate number 1, the electric current intensity passing through the secondary coil IS unknown. When we need to solve any problem, at first write the given at the following: efficiency of transformer 100%, power 24, voltage of secondary coil 12 volt, V primary 200 volt, N secondary 440 volt, unknown I at the secondary coil. Since the power equal VI, this means that IS, we need to determine the value of the current at the secondary coil, the power, divided V secondary equal I at the secondary coil. The power in the given equal 24 divided Vs. We don't need the value of the Vs, but a Vs over Vp equal Ns over Np equal each other. From the following rule, Vs over Vp equal Ns over Np equal Ip over Is. This is the rule which relate between all of them. Is equal power, this is the power, this is the voltage. 24 divided 12 equal 2 ampere. Is equal 2 ampere. This is the first unknown. The second unknown, the number of turns of the primary coil, N primary, unknown. We need to determine it. From the following rule, Vs 12, Vs equal 12 over Vb equal 240 equal Ns. Ns, we need to determine Np, but Ns equal 480 volt divided N primary. Make cross multiplication to determine the value of the number of turns. We observe that the number of turns equal 9,600. This is the result of this problem. So we can solve any problem by this method or by using the rule which used it. Another example, a step-down transformer of electric potential 2402. The first is called V primary. The second is called V secondary. The first is V primary, the second is V secondary. The number of turns of the primary coil, this is the number of turns of the primary coil, 4,000. If it is delivers an electric power, 13,500. This is the power. This is the power. And its efficiency 90%. Efficiency 90%. The rule of efficiency, eta equal Vs Np over Np Ns times 100. This is the rule. Efficiency 90%, 90 over 100 equal Vs 120 divided VB 2400 times N primary, and 4000, while N secondary is unknown. From this rule, we can determine the number of turns of the secondary coil. This is the first unknown. The second unknown, the electric current intensity in the two coils. And the two coils mean the I primary and the I secondary. I primary and I secondary. Since power equal VI, VI is the power. We can determine the value of IS from this rule. IS equal power over VS. The power equal 13,500 and VS equal 120. From this rule, we can determine the value of the current in the secondary coil, which equal 112.5 ampere. We need to determine the value of the current in the secondary coil. In the primary coil, at the first, determine the value of the secondary coil. From the last rule, N secondary over N primary equal I primary over I secondary, because the number of turns is inversely proportional with the current intensity. This means that I primary equal N secondary, I secondary divided N primary. N secondary equal 222.22 times IS equal 211.5 divided 4,000. The result equals 6.25. That is the end. Goodbye and good luck.